The hand is an incredibly beautiful and complex organ, and it's an organ that we take for granted. We use it for work, we use it for play, we use it to caress, fine movement, gross movement, power. When any of those functions are lost, the hand is compromised.
I have a residual limb just below my elbow, about 3 to 4 inches. I use assistive devices and my prosthesis in the operating room to do fine motor techniques and procedures on patients. I am the only nurse anesthetist that has one arm.
That weight puts a lot of pressure here as it wants to fall down.
There's always a challenge. Being able to carry your small child in one hand and carry a grocery bag in another. Being able to stabilize a plate in something as simple as cutting my steak. Those things are struggles that I have every day.
Fine motor skills, they still have problems with. Picking up little things, it's almost impossible to do. Durability is another issue. Cables and spectra still break through on the joints. Ligament does not pull the finger closed and ultimately doesn't let the finger open. Tissue of our hand can close that gap when you're pinching something. Products now that we have, even the best hands on the market, they're rubber with plastic, potentially like a silicone type, but it does not move like our human tissue does.
Another thing is the way the bones in the hand are connected and how important that is to not only hand mobility, but hand strength and stability.
So our solution is a bio-inspired robotic hand that combines softness with strength and all-over sensing with dexterity.
Our hand has rigid skeleton inside. When we grasp something, the rigid body, the structure is actually very important. So for the skin, we are using elastic material for now to make the adaptability when there's a contact. We have multiple electrodes inside one finger, 12 electrodes in one finger, so we can sense any contact force within this skin.
And our polymers need to be integrated with that structure so that not only will they do actuation, but the sensing by the fluid will also symbiotically work with our actuation mechanism. Polymers can be designed with functionality, with adhesive property, thermal property, electrical property, to have that level of dexterity that we need.
But just being able to customize it no matter what kind of application you have, prosthetics or somewhere in manufacturing or in agriculture, that's, I think, a big opportunity that we have and that we have built over the years with our design pipelines, what we know about these hands, how to control them.
The hand that you might want for a manufacturing process versus a hand you might want in agriculture versus a hand that this individual might need or some other individual might need could be completely different. And so our proprietary software allows us to do this kind of customization. The thing I love most about this project is the passion it inspires in everybody who's become involved.
I think what this team is trying to do is to bridge the gap of things that were not possible 20 years ago or not even 10 years ago.
They're trying to find a way to incorporate sensibility into this hand, and they already have a hand that is functioning, capable of picking up small objects with relatively good dexterity. If we can restore function to these individuals, we do something that has not been accomplished, and I feel as though we are close.